So today we're going to be looking at complement, union, and intersection. Okay, complement, we heard the word before. The complement is basically what completes. Union are two probabilities combined, and intersection is where the section that is part of both probabilities. Okay, so complement is the probability that completes it, the remaining probability. Union is the two probabilities put together, and intersection is the section that the both probabilities shared. Okay, so let's see. What does this look like? A fair coin is tossed 2 times, and the events A and B are defined as shown below. A, at most 1 head is observed, and B, the number of heads observed is odd. Okay, so the coin is tossed 2 times. I gotta see all the possible outcomes. So let's say I grab a coin. Let's say I'm here. And I flip a coin. I either get heads or tails. So I flip the first coin. Then I flip it again because it says second time, right? So I get heads or tails. Then the same thing here, heads or tails. So my possible outcomes are head, 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 tails, tail to head, and tail, tail. Those are possible outcomes. So here, there's 4 possible outcomes, right? A is at most 1 head is observed. So at most, that means 1 head or 0 heads. So I'm gonna say my probability of A, remember 1 head or 0 heads, I'm gonna say, well, it happens here, here, and here. So I'm gonna say it happens 3 out of the 4 possible cases. Because it's either 1 head or no head, right? So at most, 1 head is observed. What's the probability that that happens? 3 divided by 4 is 0.75. Okay, so the number of heads, probability of B, I'm gonna, oops, let me keep this right there. B is the number of heads observed is odd. So that means I saw 1 head, or I saw 3 heads, I saw 5 heads. Okay, so the first choice has 2 heads, right? So nah, that one doesn't work. The first choice has 1 head. Yep. A tail and a head, it has 1 head, and then 2 tails means no heads, right? So I'm gonna say 2 out of 4. So that's 0.5. The probability of A union B. Okay. So all combined, 0.75 plus 0.5. So let's take a look. What's the probability that at most 1 head is observed? So 1 or 0 heads. Here, here, here. And then B, the number of heads observed is odd. Here and here, but they already had check mark, right? So I mark them, and I'm gonna say that's 3 out of 4 cases. So 0.75. Now the complement, we're gonna read the complement. Probability of A, C, that little c is complement. We know the probability of A is 0.75. So what's the probability that is not A? The way we're going to read this is 1 minus the probability of A. AC is basically what's the probability that is not A. Complement is 1 minus itself. So the complement of A is 1 minus probability of A. If I had a complement of B, okay, so let me write that. What if I had B complement? That is 1 minus the probability of B. So now here, 1 minus the probability of A. So what's 1 minus 0 0.75? My answer will be 0 0.25. Some of you might be like, wait a minute, Mr. Leonzo, what happened? Okay. We remember that A was that at most one head is observed. So that happened here, here, and here. That means at most means one head or less, right? So that happened there, there, there. The probability of a complement, I'm looking at where is it that it did not happen. So 1 out of 4 is 25%. Good. Now, what's the probability of A intersection B? Okay, so probability of 8. At most one head is observed. So for A, let me use a blue check mark. There, there, there. And then for probability of B, let me use a red check mark. The number of heads observed is odd. So there, there. Now my question here, because this is intersection, it looks like a U upside down. Which of them all 4 possible outcomes did I check twice with the red and blue? I'm gonna say, well, I checked 2 out of 4. So remember, intersection is, I checked it with both probability of A and probability of B. There were 2 out of 4. 2 divided by 4 is 0.5. Now, let's take a look at number 24. I'm not going to read the instructions for on the top. 24 has its own. Let's say I had probability of B and probability of D. So let's say I had 2 things out here. There's probability of B and there's probability of D. I'm going to write it as 2 circles that overlap. But then I'm also going to look at this part right here, the overlapping. This is the overlapping. Probability of B and D is 0.2. So I'm going to write 0.2 on that section where they overlap, okay? Now, probability of B is 0.5. You see how B is this whole circle? Those 2 sections are B. All of it has to add up to 0.5. But part of that circle is 0.2. So I'm going to say the remainder circle, the remainder part is 0.3. You guys see that? Because the whole circle B has to equal to 0.5. Let me look at the whole circle D is 0.3. And let me highlight it right here. You guys see my whole circle D has to be 0.3. Part of it is 0.2. So shouldn't that remainder be 0.1? Because the whole circle is 0.3. Okay, I'm going to be able to complete this. Now, what do I get if I add my 3 decimals there? 0.3 plus 0.2 plus 0.1. 0.3 plus 0.2 plus 0.1. Isn't that 0.6? But wait a minute, didn't I say that all probabilities combined needed to add to 1? So I'm going to write 0.4 outside of the circles. Can that happen? Yeah. Let's say I'm looking at high school athletes. B is for those that play basketball, okay? And D, let's say those that play football. Can people be just basketball, just football? Can they be both? Or how about can they be none? Yeah, so that's why we can have people outside of the circle, because yeah, there's some athletes that don't play basketball or football. They play other sports. Okay, so let's take a look. I think I'm ready to answer all my questions here. So number 24, probability of D complement. Remember I said this is going to be 1 minus the probability of D. Complement is always 1 minus whatever is the complement of. Probability of D is 0.3. So I'm looking at this as 1 minus 0.3. So my result should be 0.7. Probability of B complement is basically 1 minus the probability of B. So 1 minus 0.5. So I'm going to get that at 0.5. Probability of B union D. Okay, so this is interesting. So all the probabilities that do B and D. So I'm going to add 0.3 plus 0.2 plus 0.1. I'm going to add them all. So the sections that are B or D or even B and D, the section that they both share. Add them all up and it should give you 0.6. Okay, that was pretty fun. I'm looking up to number 26 here. So let's say number 25. The table below represents the number of active duty military personnel by rank in 3 major branches of the military. So there are officers that are in the Army, Navy, and Marines. And it says there's a total of 201,780 officers. But there's also enlisted people in the Army, Navy, Marines. There's a total of 977,629 enlisted people. Let me add my two totals. I'm going to add the two totals of here, okay? So I add 201,780 minus plus 977,629, and I'm going to get 1,179,409. Again, I added all my totals. So where it says we're going to let O represent an officer and E represent someone who is enlisted. Let A represent someone in the Army, N represent Navy, M represent Marines. We need to find P of OA. We're going to have to find the probability of EA. We're going to have to find probability of EM. Okay, rounded to 3 decimal places. So officered Army. How many officers are in the Army according to our table here? There's 97,250. How many are there altogether? I'm going to divide this by 1,179,409. So I'm going to grab my calculator. But keep in mind on the instructions, it says round to 3 decimal places as needed, okay? So I'm gonna round this to 3 decimal places, okay? So I'm gonna get this as 0.082. Probability of EA, so that basically enlisted Army. How many officers are enlisted in the Army? There's 398,549 out of 1,179,409. 398,549 divided by 1,179,409. I'm going to use my calculator. I'm going to run it to 3 decimal places. So I'm going to call this 0.338. And lastly, enlisted Marines. So 274,748 divided by 1,179,409. I'm going to use a calculator. And I'm going to round it to 3 decimal places. So I'm going to call this 0.233. If you notice, we found out officers in the Army. We found a percentage for that. Enlisted in the Army. We found that enlisted in the Marines. If you were to find the 6 possible percentages, right? Officers in the Army, Navy, Marines, enlisted in the Army, Navy, Marines. If you find all 6 possible probabilities, it should add up to 1. I don't think you will, but that's basically if you add them all. Let's take a look at our last example. The table below gives a breakdown of 2,121 civil cases that were appealed. The outcome of the appeal, as well as the type of trial, which is judge or jury, was determined for each case. Suppose one of the cases is selected at random and the outcome of the appeal and type of trial are observed. Before I read that, let me look at my table here. All these are all the cases with jury. The plaintiff was win or reversed. The plaintiff win was affirmed or dismissed. The defendant win reversed, and the defendant win was affirmed or dismissed. So all these are the listed of the jury here. All the jury trials. There's a total of 1,441 jury trials. And then judge trials. These are all the judge trials. There's a total of 680 judge trials. Okay. I can also see the plaintiff win was reversed. There's some that were jury, some that were judged, so a total of 255, so on and so forth, right? There is a total of 2,121 cases, which I knew because that's the number that I saw up here. Okay, so we can read that table. Now here, find the probability that the trial is a jury trial. So there are going to be a few questions here. Find the probability that the trial is a jury trial. Okay, how many jury trials were there? Well, 1,441. Yep. How many trials were there altogether? I'm going to say for this first case is 1,441 jury trials out of 2,121. Keep in mind here at the end, it says round to 3 decimal places as needed. So 1,441 divided by 2,121, rounded to 3 decimal places. I'm going to call this 0.679. I'm going to say that in this example, I'm going to do 3 cases, okay? There's 3 examples here. Find the probability that the trial is a jury trial and a plaintiff, so it's a jury trial and a plaintiff win is reversed. Keyword with the word and. So it has to be a jury trial. So I'm just looking at the jury trials. And plaintiff win is reversed. So just on the jury trials, how many plaintiff wins were reversed? So I'm just looking at this 187 here. And I'm going to go 187 because it says and I'm just looking at the one case. It is a jury trial and plaintiff win is reversed. So just the one case. There's 187 cases divided by 2,121 because of the total amount of cases rounded to 3 decimal places. So my answer here will be 0.088. Now my last case, because there's 3 questions I said, let's do it in green. Find the probability that the trial is jury trialed or plaintiff win is reversed. Oh, keyword, or. So how many of these are jury trialed? 1,441. How many the plaintiff win is reversed? 187 and 68, right? I'm not going to count the 187 because it's part of the jury. Remember, when I say jury, I'm counting all of these. However, I do look at this 68 because that's the plaintiff win is reversed. So I'm going to count, let me highlight I'm looking at 1,441 and 68. How much is that combined? 1,441 plus 68. Use a calculator if necessary. That is 1,509. I'm going to divide this by 2021 because that's the total amount of trials. I'm going to round my decimal to 3 decimal places. So my answer is 0.711. Couple things here I want to emphasize. When I use the word and, it had to be jury and it had to be plaintiff win reverse. So it was just that one number. When I use the word or, I look at the juries, all of the juries, and the plaintiff win that is reversed, that is not a jury. And then I added those two. So keep in mind what I did when I used the word and when I used the word or.